Hi, hello, welcome back to our channel Chemistry with RK. Firstly, I would like to request, if you're new to the channel, please do subscribe and then don't forget to click on the bell icon to get the regular updates. In the previous lecture, which is from coordination compounds or complex compounds we say. So in the previous lecture, I have discussed the important terms involved in this particular complex compounds. So the terms which helps us to understand the concept in a better way. So I have given in the previous lecture. If you didn't watch that particular video, so please do watch it, and I'll be giving you that particular link in the comment section. So you please watch that video so that you can understand this particular video accurately. Yeah, in this video what we are going to do is we are going to learn like what could be the possible hybridizations for different coordination numbers. So in the previous lecture, in the previous video, I have clearly discussed that what is coordination number and how do we define or how do we predict the coordination number for the central metal atom for the given complex. So you please let us have some more deeper understanding about that coordination number and then the possible hybridizations. Yeah, let's see the possible hybridization and shape with respect to the particular coordination number. If the coordination number is 2, then the possible hybridization is sp and the possible shape is linear. So what does it mean? If we see the coordination number 2 for a central metal atom in a particular complex, then we can able to have two hybrid orbitals. They could be s and p hybrid orbital combined to give us sp hybrid orbitals. Such hybridization is called as sp hybridization and the possible shape is linear. Similarly, if we move on to the second one, coordination number is 3 suppose, then the possible hybridization is sp2 and the shape could be trigonal planar. But here in case of coordination number 4, 5 and 6, in each of these three cases we are going to have two different possible hybridizations and the shapes also. So if you look at this coordination number 4, here there is a possibility of having sp3 hybridization and then we can also have dsp2 hybridization. So about this, so what is the difference between sp3 and dsp2? So let us not discuss about these particular hybridization in detail here, because without knowing valency bond theory we can't be able to understand these particular terms in detail. So let us have a keen understanding about these hybridization in the coming lectures. So hope you understood. As of now, what you need to understand is if the coordination number is 4, then it could be either, like in this particular case, the central metal atom can able to undergo either sp3 or dsp2. So this is what you need to understand. And then if in case of hybridization sp3, then the possible shape could be tetrahedral. If in the case of hybridization dsp2, then the possible shape is square planar. Hope you understood. Similarly, with the same coordination number 5, then the possible hybridization are dsp3 and sp3d. If the central metal atom is undergoing sp3d hybridization, then the possible shape is trigonal bipyramidal. If the central metal atom is undergoing dsp3 hybridization, then the possible shape is square pyramidal. Hope you understood. Similarly, let's move on to the sixth coordination number 6. If the central metal atom has a coordination number of 6, then it has two possibilities again, sp3d2, d2sp3. Actually, in this particular in both the hybridized cases, the shape of the complex is going to be same, that it is going to be octahedral. Hope it is clear. So yeah, this is about the possible hybridization and possible shape with respect to the coordination number. Hope you understood. You please try to make out the notes or you try to take the screenshot of this. We'll continue. So next I'm moving with types of complexes. Actually we have broad classifications of complexes in which I'm going to talk about, this is the actually first one. Okay, so this is actually the first one I'm going to talk about, types of complexes, based upon the type of ligands attached to the central metal atom inside the coordination sphere. So we have seen what is coordination sphere, we have seen what is ligand, we have seen what is coordination number, everything in my previous video. So hope you understood well, and then if you didn't watch that particular video, please do watch it. And now, so the first type of classification of complexes is based upon the type of ligands attached to the central metal atom inside the coordination sphere. So complex compounds are basically classified into two types. So they are homoleptic complexes and heteroleptic complexes. Yeah, what are they, sir? So complexes are broadly classified into homoleptic and heteroleptic. And now, what are homoleptic complexes? The complexes in which only one type of ligands are present. So we may have only 4 ligands, or we may have 5 ligands, or we may have 6 ligands. But if all of them are same type, then that particular complexes, those particular complexes are called as homoleptic complexes. So I have taken few examples here, that is hexaamine cobalt 3 chloride. Actually, yeah, this is CONH3. How many ligands you can see here? 6 ligands. All of them are only one type, that is ammonia ligands. Is it right? So obviously it is considered as a homoleptic. Similarly, 6 ligands are there. All of them are only cyanide ligands or cyanoligands. So this is also taken into the homoleptic complexes. Similarly, here also we have 4 ligands, all of them are same type, so they are also considered as homoleptic complexes. Yeah, the next type of complexes are heteroleptic complexes, which are quite opposite to homoleptic. Here we need to have all ligands must be of one type. Here the complexes in which more than one type of ligands are present. So we can have 3, or we can have 4, 5, 6, we can have any number, but all of them must not be of same type. So if you see the coordination number, the total number of ligands are 6, but 2 are of one type and then 4 are of another type. So we have here 4 amine ligands, 2 chlorido ligands. And then in the other case also, we have totally 6 ligands, but 4 are aqua ligands, 2 are bromido ligands. So totally we have 6, but if you look at, not all the 6 are same type, 4 of one type, 2 are another type. So they can be kept under heteroleptic complexes. Similarly here, the total number of ligands are 4. 2 ethylene diamine molecules are there and 2 chlorido ligands are there. And now total 4 ligands are there, but 2 are one type, 2 are another type. So this is also belong to heteroleptic complexes. And I just want to ask you, what is the coordination number of cobalt in this particular complex? Please try to identify that. The coordination number of cobalt is going to be 6, because here, as I told you in my previous video, En, ethylene diamine, is a bidentate ligand. One En molecule can form 2 dative bonds. Two En molecules are going to form 4 dative bonds. Altogether, the coordination number is going to be 6. Okay, hope you understood. And now, with another type of classification, we are going to, I'm going to see you soon in the next video with the new examples. Okay, thank you so much for this video. See you soon. Please do subscribe, and then don't forget to click on the bell icon if you are new to the channel. Thank you so much.